In today's video, we will solve one of the most frequently asked questions in Google interviews according to LeetCode: longest absolute file path. Our task is to find the longest file path. If we have two files, we need to return the longest path. If we have only one file, we return the absolute path to this file. If there is no files, we need to return 0. Let's start from the idea. But first, we need to consider that there might be more than one main folder. The file with the longest path might be in a different main folder. The first step is to change the text to the array, so we can look at each part separately and understand them better. The next step is to create an object to iterate of our data. The initial value is 0, 0. Then we begin looking at the array. The first item is our main folder, dir. We save to the store 1, 4, where 1 is our depth and 4 is the length of the current item. Our current item is the folder's name plus 1, where 1 is our slash. Next we have subdir1. We do the same things as before and add 2, 12 to the array. If we see a file, we are ready to find the longest path to it. We add the size of the file name to the last value we saved. In this case, it becomes 12 plus the size of the file name, which is 22 in total. Then we have subdir1 with a depth of 3 and a path size of 23. We keep going. Subdir2 doesn't change the value in our store because they are the same as before. We just update our store and continue. For subdir2, we do the same, just update our store and continue. In the end, we find the longest path to a file. We add the size of the file name to the last value in our store, which was 23, so our final answer is 32. This is how we plan to do it. Let's write in our solution. First, we initialize a variable named max to 0, where 0 is default maximum value. Next, we create a store to keep track of data, setting its initial value to 0. To iterate the array easily, we define a new variable r and split the input into array. Split function takes /n as a pattern and divides the string into an ordered list. So now we have an array similar to what we have in the picture. We can also write return max at the end of the function. Now we set up a loop using for-of to go through the array. Inside this loop, we work with each line as a string, where our string will be variable line. To figure out the depth of the string, we use the last index of function with /t as a parameter, adding 1 to the result. So let's create a new variable depth and add line.lastIndex of /t plus 1. This plus 1 helps us set a default depth of 0 for root items and correctly determine the depth for other items based on the number of /t's present. Then extract the name of the current item, which would be a folder or file, using the substring function with depth as a parameter. So let's create a new variable name and write line.substring with depth. This gives us the correct part of the string, separating depth and name. So let's finish it. And the next one, we identify if the current item is a folder by adding a new variable isFile. We use the indexOf function with a dot to check if the string contains a dot, which indicates it's a folder. So, if it's not -1, then the dot present in the string. We then set up if statement based on the isFile variable. Let's start with if isFile and we start with else block. In the else block, we update our store with e of depth plus 1, adding a plus 1 to our count for the slash that separates items in the path. This +1 is also used to denote the additional of a slash to the path, which increases the depth by 1. We calculate the new value by adding the length of the added item's name to the total path length at the added depth, plus an extra 1 for the added slash. To make our solution more readable, I suggest to create one more variable for our slash and replace all +1 numbers which should add slash by a new variable. So let's create this variable slash equal 1 and replace everything what we have in our else block. Finally, let's complete our if statement. So if each file is true, we update the max value. Let's write max is equal, and here we compare the current max value with the sum of the current depth and file length, choosing the larger value. So let's finish it. We need to write store depth plus name.length. We don't use +1 for the slash here because we already added the slash in else statement, so it will be extra slash for us. Now we can run our test cases. Let's change the layout to see the result and run it one more time. Everything seems to work well. So let's submit our solution. And it works as well. To talk about the time complexity, it will be O(n) multiplied by m, where n is the number of lines and m is the length of the string. Although it's not maybe the optimal complexity, you are welcome to propose better solutions in the comments. Space complexity stands at O(n), which relates to the number of lines in the input string. The store also has complexity of O(n), but it simplifies to just O(n). That's all for today's video. Bye.